Forklift.
It's going to be the best forklift ever restored.
Back it up.
Today we're going to be doing a little bit of engine machining with my mates here at Classic and Modern in Bracknell. Now, having stripped and cleaned our forklift truck engine's block, we can now bore it out and then press in some new piston liners, and then all of that is going to happen inside this labyrinth of engineering excellence. So let's go and find Adam. Hello, Adam.
Oh, hello.
Good to see you, sir. Right, so you are the man in charge of making our forklift truck engine completely usable, is that right?
Yep.
Awesome stuff. So that is our block here. So I guess we're going to pop it onto here.
Yep.
The first sort of stage. So this is the machine that's going to be doing the boring, is that right?
Yeah, this boring machine, and this head just goes down and up and then rotates, obviously.
Okay. Take me through what kind of controls this machine has to operate.
It's quite a simple machine, really, because you literally just got start the machine, stop the machine, 2 motor speeds, move the head up and down really fast, and this just sets the feed going.
Okay, so that's actually, it's very simple.
Very simple, yeah. I'll do a slower, bigger cut for the first cut, and then I'll do a quicker finish cut at the end. Okay. So we're fitting liners to it.
Yep.
So we'll measure the liners, we'll bore the block out to take the liners, we'll get 2.5 hour interference, so they're nice and tight.
Okay, yes.
Bit of Loctite in there, and we'll put the liners in, push them in on the press.
Yep.
We'll then bore the liners to suit the pistons, 4th hour undersize, and then we'll use a hone to finish it.
I guess we have to get it level, get it all set.
Yeah, get it all level set, and then we can set it up to the bore.
So this bit sort of stays the same if you actually move the engine.
Yeah, the bed moves back and forth.
Gotcha, okay. Okay, wicked. Let's go for it.
I've already cleaned the bottom of it.
Lovely.
To make sure it sits flat.
Yeah, I hope you appreciate how lovely and clean this is. We did wash it. So basically you do this to all kinds of engines, right? So you know, if it's a V8, do you actually then have to tilt it, you just have to block it up in a certain way?
We have a special jig that bolts onto here, and it's air operated. And
that's cool.
You can do 60 or 90 degree in.
Okay.
Or Ferraris and that as well, like V12s.
Yeah.
This machine's all full manual, so I have a little setter in there. I just have to
that's cool.
set all the cutters by hand.
Yep. And how long have you been sort of playing with engines?
I started it when I was 18, I'm now 25, so.
It's not bad going. The good starts, you're going to take after Paul. You know?
Yeah. Most people start when they're young. Everyone starts the same way of cleaning, clean crack testing, stripping. Quite a lot of the Perkins have flange liners that you just only have a couple of foul interference.
Okay.
And you can just slide them in and out.
Yes. But not this one.
No, not this one, no.
That's okay.
Yeah, and just checking the 4 corners to make sure it's flat.
Yep.
So if you don't want to bore not straight.
No. Right then, so this is the dial gauge. So there's basically, when you kind of move that probe at the bottom, it just spins the dial. So you can now then effectively measure very accurately kind of the height, which is what we're trying to get here. We're trying to get it super flat, aren't we?
Yeah, so if I set the 0 to this side, and then bring over here, it's 3 thou lower on this side. So I need to bring this side up, but I'll check the back end first. So it's 0 on this side and +3 on this side.
Now, is that just the casting? Is it?
It's probably happened over time. We get quite a lot of it on old engines. Well, it's 3 thou low on this side and 3 thou high on this side. Unfortunately, this machine doesn't have a way to level it other than paper. So we have to use paper.
We're going to use paper. That's brilliant. Yeah. This is where we get Paul to get his wallet out and just, you know.
Oh yeah. Yeah. So I'm just putting paper underneath it to level it out. Each bit of, like a normal bit of A4 paper is normally about 2 thou once it's compressed on here when I've done it up, and then a bit of receipt paper is about 1 thou. So
that is as high tech as that. So it's receipt paper or writing paper.
Yeah.
That's amazing, or printer paper, I guess. That's amazing.
When stuff's level, it is level on this machine. Like Porsches, we do a lot of Porsches, they're always level.
Yeah.
Perfect. Thou on right, 1/2 thou.
So that's 1/2 thousandth of an inch. That's not very thick, is it?
So I'm going to check the bore, run the gauge down it as well, see if it's straight.
Oh, I see. Yes. Okay, that makes sense.
Because sometimes you level the bottom out, but then the head face is what's out, so the bores are still not.
Oh, I see. So so somebody's machined. That's really interesting.
Yeah, sometimes the sump face is out, sometimes it's the head face.
Right. Okay.
So here I've got all my cutters and that, doing loads of different jobs. Flat cutters, normal cutters, drop cutters, and holders. And then I've got this for checking bores.
Oh, so the machine. Oh, I see. Okay, that's clever.
So
the machine actually has a gauge just on the front here.
Yeah.
So it's basically the same thing as that, but it's actually built in.
Yeah.
Okay.
Just checking the actual bore. So I'm just putting this in here, because this uses this dial to check the center, find the center.
Oh, that's really clever.
and I'm doing it just above the wear, because in the wear it won't be central.
Oh, of course,
it would have
yes,
worn
yes.
more evenly.
Yeah, so you can see those marks on the top here. That's actually where the pistons didn't get to.
Yeah, it's above the ring groove.
Yeah. It's getting very close. Oh. So it's slightly oval in shape.
Yeah. So each one of these is 0.01 of a mil, so that's what, like 4 tenths, I think.
And now what you're doing, so now you've established the centre, we're now going up and down to actually see how straight or how vertical effectively that bore is.
So you can see the wear there, you can see it's getting further away, and then when I go back up above the wear, it will come back in.
I mean, the bores have scored a little bit, not crazy, but obviously when we put the new liners in, then that's going to be completely pucker, and then you're going to then put the new pistons in with all the new rings and everything. So that's just going to keep everything sealed properly, where right now, it's quite leaky at the top of the engine, I guess. Okay.
And you've got pitting as well, haven't you?
Yeah.
A bit of pitting in there as well.
That was after a bit of honing. It was quite bad before, or even worse.
Yeah, so now we've got the machine set, we're going to check the liners.
Okay, so these are our new liners. So you're now going to bore this out so they fit in, but it's going to be presumably a bit of a
interference.
Fit. Yeah, so what kind of interference fit are we
going
for?
We put 2.5 out interference on this.
Okay, so basically the interference fit, if you imagine there's the kind of holes, you have holes and you have kind of, I suppose, cylinders, and then there'll be numbers for each of those, and then depending on how you go, depends on sort of like the difference between whether the hole's too big or the actual cylinder's too big, and then you're going to squish them into each other. The interference means that normally they'd fit inside and sort of stop around, be fine, but then actually that'd be like a clearance fit. But then an interference fit is when they're actually touching, so you're kind of like trying to push the metal together, just kind of mishing it in. But we don't want to be doing it so much, otherwise you'd never get it in all the way. So is this machine going to be pressing it as well, or is it?
No, that presses there.
You've got to press for that. That's clever.
Yeah.
Okay. So Adam, now we know that this is actually perfectly in line with the centre of that. We also know that this is straight.
Yep.
Pretty much, we're happy with that. We know it's wall at the top. That's what we're going to fix now, and we know that the block is now flat.
Yeah.
And so everything's now in correct position.
Yeah.
So now we're going to start doing damage. Good damage.
Yeah, we need to measure the liners first.
Right. Okay.
Set them up.
Good old-fashioned micrometer.
Yeah. Can't be in.
Proper.
Make sure they're all the same size.
That's a good question.
It's half hour oval, but it's quite common. Liners.
Okay.
Even big company liners are normally oval.
Okay. But then presumably when you squish it into here, that's going to fix that as long as this is okay.
I measure in 3 places as well, because sometimes you'll find that a liner will taper off.
Okay. So you can see on the top there, you've got a little chamfer compared to that end, which is square. And so the idea is that basically that's obviously the easier way to get in. What Adam is saying is if this was tapered, sometimes they are, then of course then it's just going to flop about in the hole, isn't it, basically? And so they're brand new, they're a bit wonky, but they're okay. Is this engine a different interference to normal, or is it always pretty much the same?
We always do the same. A bigger ball like this would do 2.5. If it's really big, we might do 3. Aluminium, we do 3.
Okay.
Because aluminium
moves around a lot.
Moves more, yeah.
So,
like with aluminium, we heat blocks up, put liners in.
Right.
But you don't get a lot of difference with cast iron, so we don't.
Right. So it makes no difference. Okay, fine.
The hole's going to be 2.5 thou smaller than a liner.
So we're actually, where this was originally misaligned by 3 thou, so basically we're talking a receipt and a bit of A4.
Yeah. Yeah, basically.
Brilliant. Go for it.
So I've set the setter to 3.5, 3.5.
Okay.
Because that's what that's going to be with interference. And I've set the clock to be 0, so now we can check the bores.
Okay, so that now has become our super important datum.
Yeah.
Right, okay.
I'll take 3 mil, max probably.
Right.
With a slow cut, and then a finished cut, I'll only do like 20 thou.
Right, okay, yeah. So, because presumably depending on the speed of the feed, is depending on how much kind of ribs and stuff you're going to get in the metal, and you need to then get that off as finely as possible, Well, carry on. Sorry, I'll shut up.
That's all right.
So you've got some cutters here.
Yeah.
And then you've got the springs are pushing the cutters
out, so you can set it easier.
Yeah.
And then I've got holders. We've got multiple different sizes, so you can bigger bores, smaller bores.
Cool. Okay, cool.
This, to set a cutter, it's in metric, where everything else is imperial.
So you're getting really good at conversions in your head.
This isn't perfectly accurate, because every time you sharpen the cutter, it changes slightly.
Yeah. So essentially we've got the cutter's going to go into here, and then because Adam's actually set that distance, we want it, say, at that height, but he's actually going to go slightly smaller, and then the idea is that then, of course, we've got a little bit of room, and we could also find out kind of how everything's cutting, how it's working, because...
This block could be really hard. I might have to go a smaller cut.
Yeah.
You don't know sometimes. So I just bring this down just above.
Okay.
And then I'll set the cut going.
Now this block looks quite close to that, is that?
That'll be right.
Oh, he's a professional, isn't he? Look at that.
So literally just press start. I'll start by hand quick, see how it's cutting. Sounds alright, so I'll set it going. At the moment, I'm just listening to it, waiting for it to come out the bottom of the bore. Oh, let's hit the stop. So on this machine, it's very simple stop. You just pull that down so it stops and then do this up. And then every time it will stop at the same place. Because we come out the bottom of the bore now, so it's just a set of stops so you don't smash into sight. We took about 1 mil out of it in that first cut. I normally will do more, but that's quite a hard block.
Yeah.
It's not struggling as much, so I would say it was glazed before. It had a hard glaze on it.
Oh, right, okay. I just had a little chat with Paul about the glazing of the engine. It's something you hear of quite a lot actually on some cars, and it's all down to the heat. Now, because this is running LPG, it's actually kind of burning a little bit hotter perhaps, and it's obviously it's a lot drier, and it does quite a bit of damage. So what's effectively done is heat treated the bore, so it's kind of made that little skin a bit like anodizing when you kind of put a little hard coating onto slightly softer metal. It's the same sort of thing. So we've now got slightly harder sort of bores than we might have done. But now obviously we machine through that, that's going to be fine. The liners are going to fix all that, and hopefully we'll get many more, well, hours and hours and hours of running time. But the downside is, he's also pointed out the fact that with LPG converted engines particularly, all the taxis back in the 80s, they were running so kind of hot, but also without any kind of lubrication, if you like, or any protection. So that the valves kind of pound themselves into the head to end up destroying the heads certainly on the taxis. So with our forklift truck, hopefully it's designed to accommodate that, but it means we may have more work to do on that just to get our thing to actually run. Oh, now we're getting close.
Yeah, we've got 43 fouls come out of that. This is a foul clock, so one rotation is 40 foul. We've got 43 fouls come out. That's just over 1 mil. You do a little cut, check it, because otherwise if you spend loads of time just doing loads of little cuts.
Yes, it'd be pointless.
Because you've got to slowly work up to the finished cut. Every time you face the cutter, it changes a little bit, so you have to work up to every time.
And it's really hard to put metal back on.
Yeah. Well, liners are putting metal back on
Well, that's true.
Couple of temps tighter.
Okay.
But I'm all right with that.
Yeah, cool.
A little bit tighter is better than a little bit loose.
Yes, that makes sense. Is the press, you're going to be able to push it in enough?
Yeah.
It would just split the block perhaps, or is it going to just distort stuff, or, you know?
Well, I've never had a problem putting any lines in.
You've always got it right.
Yeah,
I like it,
yeah.
So this will probably be the last cut on this.
Yeah, this will be the last cut.
And well, I'm interested actually, you're not using any lubricant?
No. You don't really need it for cast iron with boring like that. We do it for alley.
Right, okay.
We use paraffin for alley to.
Okay.
Because aluminium, when you don't put lubricant on it, it just don't cut nice at all. It just goes like really rough
really
and like
chewy and
yeah. Just all, it can get stuck to the cutter, but cast iron don't get stuck to the cutter.
It's quite tense.
Yeah.
But I'm really worried about my head now, because I think that's going to be a problem. I think that could be where it's all going to go wrong. I'll get John to take all the studs out and bring it over. So how are we getting on? So this is now obviously the third bore, and you're some way down now. So how is that compared to the first two?
Well, the first one had bad glazing, and it took me 4 cuts to get it the same size. But I only have to do 2 on the last 2 bores. The glazing hasn't been bad; it's not been hard.
Oh, that's really interesting. So this obviously has got a lot hotter in the past, perhaps, and that's obviously what's caused the glazing. Whereas these seemingly better. So maybe there's a blockage in the waterway, perhaps, or something. But
yeah, it might be a blockage.
Well, that's the problem. So this obviously came to us. The engine was in a box on the sort of the forks where the forks should have been on the forklift truck. So perhaps there are more reasons why it was actually that way when we got it, rather than just the fact that it was scoring in the bores. But now we've started, we will be finishing this. We're going to have to do everything, including the head work that might be needed to actually get this to actually work properly as a proper engine. Yeah. But we've come to the right place, that's the main thing. So while Adam gets on with the boring, let's see if we can find Paul, who owns this amazing cornucopia of magic. It's incredible. There's crankshafts all over the place. There's blocks all over the place. There's heads all over the place. I mean, they do everything. They do all kinds of engines. He's going to be here somewhere. Aha, hello sir.
Oh, hello, mate.
All right, Paul, how's it going? Good to see you.
Right.
Thank you very much for squeezing us in.
Oh, you're welcome.
Because I appreciate that you've got a lot of stuff going on, haven't you, really? What have you got going on apart from our wonderful
We've got just about everything from V8s to V12s to straight sixes, Porsches, and we've got everything.
And then you obviously go from kind of modern stuff right the way back as
We
well.
go all the way back.
Yeah.
Our oldest engine here at the moment is the Star 1910.
That's not bad, is it? That's not bad at all.
That's not bad. That's our oldest engine, right to the modern one.
It's nearly as old as yourself, probably.
No, it's younger than me.
So how? Yeah, that's a good point. How did you get into all this? I mean, what kind of inspired you?
Well, I started when I was 14 years old, and I never wanted to come into this industry, but I enjoyed it so much I just stayed. And
that's cool.
And I bought it in the end.
Yeah, yeah. And then how long have you kind of been here, or sort of?
Well, this has been my business for about 27 years now.
Wow.
Yeah.
Okay.
So
That's amazing.
before I was manager, and then it just
It made sense to take over. Yeah. Well, show us around, please.
Yes.
Let's have a look. What can you show me first?
Well, we'll show you. We've got as a TR6 here. What we're just doing. We've just a full rebuild. It's a bare metal strip. All the galleries out. All the core plugs are out. We boil the block inside out with ultrasonics. Clean it. We line hone it. We line bore it to put camber ends in it.
Wow.
We grind the crank. We do absolutely everything to it. We machine the head face.
Yeah.
The block's all cleaned, machined. It's bored, lined if necessary. The heads has all new guides. All the faces are machined on it. All the seats are cut, hardened seats put in. Wow. The cams are reprofiled or new ones.
That's amazing. So it's literally like
it's like
building it from scratch as it was in the factory.
Better tolerances than the factory was.
And also, of course, with the hardened valve seats and stuff, it's for modern fuel as well.
Yeah, and remember, it's 50 years old as well.
Yeah.
So
So we're all feeling our age at that age.
It's all good. So we've got lots and lots of stuff going through of all different types of engines.
Is that a V8 or a V6?
V8.
V8.
Yeah.
Couldn't see the other piston. That's
327.
Cool. Nice.
What else we got? If you have a look around here, there's all sorts of blocks. Heads we're doing there. The Ferrari 308s.
That's funny you should say that.
You know.
We may well need your services on that vehicle.
We do loads of Ferrari stuff.
Really?
So, a lot of Ferrari stuff.
Are there any things we should be aware of with our 308? I mean, because obviously we don't even know if it runs yet. But
the problem is the liners are always worn around. The liner seals are always corroded.
Okay.
Because it's such an old car now.
Yes.
The valve guides are always worn out.
Wow.
But we can do it all.
So can we? I mean, is there any of that we can sort of detect before we have to strip it down?
Well, you can do. You could pressure test it. You could do a leak down test it. You can compression test it.
Okay.
Oil test it. There's loads of tests you can do before you rip it apart.
Okay. Well, so I think we'll do all that, and then we'll come back and grovel for help.
So
that's amazing.
What else have we got here?
Is that like a little flathead? Is that a flathead?
That is Fiat Bellina. It's 32 horsepower. When it's finished, we're hoping it's going to be about 62. I made a crank for it. I've forged pistons, forged
so
con
you
mods.
actually made a crank, so you've cast
Yeah, we
it
made it here. No, we made it here.
Oh, that's
There's a whole crank there on the bench.
A big chunk of steel.
We made that out of one piece of steel.
Wow.
But I wouldn't make another one because it's a labour of love, and I'm not geared up to make a crankshaft. I can grind it and machine it, but to hog all this out on a lathe.
Yeah, that's a lot of work.
There's a lot. There's hours of work.
But now you've got the design, and would you send something like that out just to get it seen?
I've never seen one before.
Okay.
No,
I don't suppose there's much demand for that, is there?
No, it's a one-off. It's just a project, really, what I took on, which I shouldn't have.
Okay.
It's just,
We've all been there.
It happens, doesn't it?
Ferrari 308's been the start of it, let alone like Range Rover.
Yeah, so we have approximately probably about 80 to 90 engines on order at the moment.
Wow.
Going through the workshop of all different types.
And that's, I mean, so then how many would you do a year, do you think?
Oh, I don't really know, because some engines take ages and some are pretty quick. You can do one in a day sometimes.
Okay.
Put together.
Yeah.
But then you've got the machining process, and you've got some of the rare stuff. You've got to get the parts, parts manufactured.
Of course.
It's all got to come together.
Yeah, okay. And then how do you about the staff and stuff? Because obviously it's not easy these days, I imagine, to find them. So how do you go about that?
We have quite a lot of young staff. This is Lewis. This is my son. He's building a TR4 head for someone at the moment.
Awesome.
He's 18 now.
Okay. So he already knows everything he needs to know.
Lewis knows most things.
Yes.
Same as my other son, he's probably been working there since about 7 years old.
Okay.
So he knows he can.
And that is completely legal, obviously.
He knows his way around an engine.
No, that's fantastic.
Yeah, so
that's really great.
they will learn.
But presumably you can't just keep having more sons to train them up. I've
got 3 sons here now.
Okay, you have?
Yeah.
So you haven't just having more.
We've got another one here. It's an Aston Martin DB5 we're doing here. We're cleaning up, but look, as you look at that, can you see the crack there? all around there.
Oh wow, yeah.
It's all distorted.
So how can you fix that?
Yeah, we cut that out and we'll weld it all back up again, make it look like new.
Yeah.
At the moment we're cleaning it and assessing it. There's loads of threads in it doing it and loads of other work. So
is this a line boring machine?
Yeah, that's the line boring machine for the bigger jobs we do. Yeah. The heavier jobs, because that will go the whole length for that.
Yeah.
The most jobs I've done on the line bore are on my small BT6, which you'll see next door.
Yeah. Because I mean, we've got a big old Cadillac, a 1916 Cadillac and an 18, and we've had the Babbitt bearings cast.
Yeah, I could bore them on
So
this.
you could bore those out on that?
Yeah.
Because it's big. I mean, it's a big old box.
Yeah, I know. Yeah, I've got one next door.
Yeah. Okay.
Yeah.
You do everything. I love it.
A crank balancing machine, which I had made about 25 years ago for me in America.
Oh wow.
It's fully computerised.
Okay.
So it's driven off a motor in the centre. So it's driven
I see.
off the
So
middle.
then it just spins on these.
It's got a sensor here and here.
Yeah.
And this just gives you RPM indication and position sensor.
Yes. So it's a bit like a tyre balancer in a way. Essentially, it's just sensing where there's a heavy or light.
Yeah, pretty much.
And how do you add weight? I mean,
Well, you drill through the side and you put heavy weight in.
Okay.
Heavy metal, tungsten, carbide slugs.
Okay. Wow.
So this is what we would do now. We put all our information in there.
Yes.
And we come out of that program. And then we're going to 1. And that'll give us our pulse.
I see.
As that spins,
Yes.
that will tell you where to put it. This will give you our drilling chart and it'll tell you what size drill and how deep to go in either end.
Yes.
But it's never that simple, as you can imagine. This will tell you crankshaft positioning and RPM.
Yeah.
It's all calibrated for 500 RPM, this machine.
Yeah.
It will tell you where to put the hole, or where to drill the hole to add metal, or take metal out.
Oh yes, you drill it in, put the heavier weight in, or grind something off.
Or grind something off.
And of course, I just realised it is a pillar drill. So is that what you use essentially to drill the hole?
Again,
yes.
this all floats on air.
Oh, that's good.
So you can lock it and put it where you need.
Yeah.
To be able to do it.
That's nice.
Fortunately, you haven't got to do your forklift, have we?
No, we haven't, which is good. But on this machine, is this for valves, perhaps?
Well, if you come to see Lewis here,
okay.
he will show you. Do you want to have a quick demonstration? It's a very clever machine. It all floats. The whole thing floats on air.
Oh, I see.
So
put the foot down and pedal it underneath. And
so it's actually lifted the whole of this up.
The whole thing's floating.
Back and it goes across. And if you want to go into your seat, put your pilot into your guide.
So that's really amazing. So actually it self-adjusts.
Now watch. This all floats now to centralise.
Okay.
So
that'll be
that's it, centralised.
your guide.
So now is this perfectly aligned?
That will cut a perfect seat now.
Okay.
Yeah.
And then the actual cutter is just here.
Yeah, which you can use.
The guide.
You use a 3-angle seat, a 45 degree, and cut any angles you want.
Yes. So a 3-angled seat would be for like a kind of a cosy or something.
No, well, we do 3-angle seats on a lot of stuff to make it more efficient.
Okay. Because basically the air hugs to the corner, doesn't it?
Yeah, then you get a better airflow from it.
Okay.
So you get a better combustion cycle.
Yeah.
So this is where we will be doing some crack testing over here.
Okay.
We pass a negative and a positive current through, and we spray a dye over it, pass electric through it.
Oh wow, and then it collects in the crack.
Then we pass an ultraviolet light over it.
Yeah.
And we find your crack.
That's really smart. Now, I mean, presumably most crankshafts
We
don't
crack
get
test every crank.
Oh, you do? Okay.
Yeah, the reason for that, a lot of them have got cracks in.
Right, okay.
We had I think it was a BMW M54 the other day,
Yeah.
cracked. It hadn't even gone wrong.
And then can you repair that? Or you
straight
just
away.
start again? Right.
Straight away. Once it's cracked, that's
Yeah.
it, really. If the surface is not great, you grind it.
Right, fine.
Because you've got 100% good job done.
Yeah, fair enough. And I suppose while it's all apart, why not?
Force the comedy not to do it.
Yeah. It looks like somebody's been on holiday for a day.
No, we've got containers of cranks to do. These are all customers.
That's amazing.
Yeah.
So how many of these would you do a year roughly?
Oh, I don't know.
Thousands, I guess?
I don't know. How many cranks we've done this month, Grant? With all those V8s you've done?
If I say 8 a day.
8 a day? Yeah, so it's many thousands then.
A lot of cranks.
Thank you. Well, come on, crack on. How rude. I don't know. So you have so many machines. I mean, I guess there's lots of different processes.
Oh, there's loads.
So what is talking of processes, what does this sort of machine do
This
here?
is a valve facing machine. So if we wanted to face a valve like that, we'd machine that face there, the 45 degree parallel air chuck.
Oh, that's cool.
You can
Pop that in there. Yeah, and then so you've got a grinding wheel there, and then I guess...
face the valve at 45 degrees.
Oh, that's cool. I'm sure, I mean, so again, when you've got an engine in bits, is that just a matter of course?
Yeah, we do it regardless.
Anyway. Okay. So we'll be seeing our forklift truck here as well?
Yeah.
Look, clearly you've got a big washing machine over there, but also there's this, I think, is
This is the head-facing machine, which runs PCD or PCB, which is diamond or crystallised carbide.
So it's like a big, like a fly cutter, basically.
Yeah, but it's quite a clever bed. It tips at all angles to clock stuff up.
Oh, that's smart.
Very clever, very quick.
Yeah.
We can do blocks on it, heads, anything.
Okay. And I suppose, because nowadays as well, the modern gaskets, they're quite hard, aren't they? They can dig in.
They need to be dead flat. Yeah. Yeah, if they're not flat, they leak. So it's imperative that you always face everything.
So we'll be having the head and the block on here later then, I guess.
Yeah.
Nice.
Yeah.
Awesome. So there's another room as well.
Yeah, yeah.
Okay.
Let's go in and I'll show you what we do in there.
So have you just been buying more and more buildings in this row?
Yeah, it's going to be the dyno cell, yeah. We've got to knock through and put the dyno in here, but we haven't done it yet.
That's
it's just, didn't need another 100,000 quid to put it in. So,
okay, just another 100 grand, why not?
Yeah, there's, as you see, there's lots of...
Has he got a lot of heads there? What's that?
They're all MGBs. We do quite a lot of MGBs every month.
Every month? How many to do every month?
About 160.
That's ridiculous. How many, I mean, MGB heads that bad, or just...
Well, they are that bad, yeah, because they're always cracked.
That's amazing.
Yeah, but
I mean, how many did they make in millions? I guess.
Oh, I don't really know, but most of them went to America.
I mean, where are you getting them from? Are you making them yourself?
About 35 years ago, it was my project to do all the pattern work to make them.
Oh, that's
and now I've got the job of machining them all.
Oh, that's interesting.
So I machine them, put them together, finish them, and they go out abroad somewhere or go wherever in the world.
Well, this is great. So basically, that work is going to keep MGBs on the road. Well, at least that bit of the MGB on the road for indefinitely.
Yeah, well, I've got a lot of MGB stuff. I do a lot of MGBs full race, anything to a road car to a race car. So,
And do you cast any other heads on any other vehicle?
At the moment, I'm just doing the crossflow MGB.
Right.
I've just literally done.
You're really obsessed about MGBs.
No, it goes in the TVR.
Oh, okay.
So I've just done those. That's the project I'm working on at the moment.
Nice.
I've also done the TR4 head as well,
wow.
which I've got to perfect.
Yeah.
So.
But there are so many engines out there. I guess the thing is, I mean, you clearly across most of them. I mean, is there anything you won't touch? You know, or just don't go there?
No,
you'll try everything.
I do just about everything. Yeah.
Everything from forklift trucks to Ferraris.
Yeah.
Fantastic. Well, on that note, thank you very much, sir. I will crack on and let's just go and see how Adam's getting on with our boring. Awesome.
Too much time to fight for ourselves, and we will never be boring.
Go leave the paper where I took it off, and I'll make sure I put it in the same way.
Oh, clever. Okay.
Even though when you've pressed on it with quite a lot of force, it changes sometimes.
Of course, yeah. Another advantage of not doing the coolant.
Yeah.
Right, so now we're onto the press.
Yeah.
So now this is in position-ish.
Yeah.
I mean, obviously the pressing is relatively simple, isn't it? I guess you're just going to bang the liners in or squish them in.
Yeah, push them in, make sure they're clean because you don't want oil behind a liner because it's easier from slip.
Oh, I see. Okay, fantastic. Carry on, sir. Carry on. And what are you cleaning it with? Just a bit of...
Just brake cleaner.
Okay, yeah.
I tried to wire the brush this one earlier because I had a bit of corrosion on it.
Oh, okay, really? It's been sat in the workshop so long. Okay.
Yeah. I'll put a little score on the liner with a vernier.
Yeah.
And when we get close to the score, I'll stop, check how close it is to the bottom, and then just tap it down a little further with the
okay, that's cool.
You don't want it sticking out too far because it'll hit the crank.
Yeah.
Because those lines are a little bit longer than the ball.
So now you're putting some Loctite?
Yeah, just a very little bit of 638.
So what is 638? Is that actually...
It's quite a strong one.
Okay, so it's going to really hang on to this?
Yeah, it's also there in case any water gets around it. It will stop any water leaking past the liner into the oil.
Okay.
Yeah, I'm going to get a liner, get it straight, chamfer them down. Let's do a little tap to get started. If you keep pushing at a slight angle, it'll just break the liner eventually.
Yeah, of course. Yeah. So you're letting it kind of reset.
Yeah, get back to where it's meant to be.
This is where your score mark comes into its own.
So level there, but a bit low there. I'll just do a little bit more. It's right on the edge. Oh, tap it a little bit further.
Cool. So that's good. So okay, so one's in.
push it, yeah.
You're so good. You should do this for a living. I mean, it's just brilliant. So this is now where our special bits of paper come back into their own.
Yeah, I'll check it first, just see if it's moved.
Oh, okay.
And then I'll use a bit of paper. It's the same out as it was before.
Okay.
So I'll put the paper back and then check it again.
Okay. So it's not got any better.
No.
It looks shiny, which is cool. So really we're just rechecking the depth. We've got our paper back in position. We're just making sure that it's now as flat as it used to be.
Yeah, it's about half out, which it was before. But that's half out's nothing.
Okay, fine. We'll let you get away with that, I think.
Yeah.
So this is where smoking roll-ups really comes into its own, isn't it? That's the same.
Yeah. Well, cigarette paper is actually too thin.
Oh, that's interesting. You need so many of them.
Yeah, like it doesn't. You put it under, it doesn't even make a difference.
That's amazing.
A roll of receipt paper.
No, absolutely. Depends what you buy first, though, doesn't it?
Yeah.
Yeah. So now this is all good. So now we're happy that it's flat again.
Take the lip off one bore it. Next bore, take the lip off, bore it. Because it's easier when you set up on one instead of just keep setting up and then going back across. Setting up on all of them, doing the tops. Yeah. Then setting up again, doing all the boards. It's easier to do one at a time.
Yeah, makes sense. So basically, pushing it in has actually distorted it again. Well, you said it was oval before, of course.
Well, 0.02 millimeters oval, which is 8/10-ish, I think.
Okay.
So it's like nothing.
So 8/10 of a millimeter.
No, 8/10 of a foul.
Of a thou, okay. Yeah, wow, okay. I mean, that's mad to think that back in the day when engines were handmade, like even the screws would be done individually, they wouldn't have any standards.
Yeah. We had a lot of clearance back then.
Yeah.
Now you get stuff like Nissan Micra has like half foul clearance, but then you get something old that's like 7 foul.
Yeah.
You said it was natural aspirated, not turbo.
Yes, that's right, yeah.
2 foul to 4 foul on natural aspirated.
Oh, I see.
And then 3 foul to 5 foul on turbo.
So and that, I guess, is because the turbos run hotter.
Yeah.
So then you need a bit more, a bit less shrinkage. The turbo engine is going to be running tighter than if it was the same engine than a normally aspirated engine. Yeah. And I guess the LPG, because then that does run slightly, well, it's drier more than hotter, isn't it, I suppose?
Yeah.
But
I'll probably just go in the middle, so it's 3 to 5, I'll go 4.
Fine.
4 foul clearance right in the middle.
So this is now going to basically cut the top of our liner down, so it's the same height as the block pretty much.
Yeah.
And then obviously then we'll face the block later, but this is just to get it, because you can see there's quite a lot of excess there.
Yeah, if you were to face that, it would take ages, and it'll probably crack the line as well, because it swings round.
Like, of course, yeah, it's just really giving it a hard time.
Yeah.
That's very satisfying.
Yeah, that's pretty level. Then when it gets faced, it'll get perfectly level, obviously.
Yeah, okay. We're literally just digging out the bore, bang it in the line, remachining it and stuff, but obviously it has to be right. If it's not right, then there's no point doing it. It needs to be really nice and precise, and obviously things like the tolerances here, just to make sure that the pistons don't get stuck, but also they're not flopping around either, because obviously they've got to be just right. It's all about Goldilocks, basically. It does seem suspiciously shiny.
Yeah, it does look a bit like chrome, but you can normally feel like a bit more weight when you're bringing it down with the when you're doing the flat car.
It's going to be the best forklift ever restored.
I'll let it cut a bit and I'll check it, move it out because it won't be on size yet.
So these are built, they're kind of made undersized deliberately so you can get it right now, yeah.
The problem is if you had it a finish liner, which like, do you know you're on about Perkins earlier where they normally drop in and out, they're finished, but then because they're interference fit, when you put them in,
they're going to change shape anyway. Yeah.
So then you have to hold them anyway, so it don't really help. That should be it. It should be about 4 foul left, and I'll hone that out.
So you can barely see that now. So that's that's 0.2, wasn't it?
2 foul.
2 foul. Yeah.
So it's just basically just changing colour as far as you can see. Okay. Yeah, that'll be set. I just move it from that one, take it out, flat cut the next one, put that back in, do that. So I want to flat cut it first, because I don't want this to get too thin at the top, and then flat cut because it might crack.
No, of course. So as you say, to get these back out again, you'd have to re-bore them.
Yeah, I bore them until they're really thin, and then you get a screwdriver down the side and just flick it and they'll crack and fall out.
Yeah. So now, our new liners, you've kind of basically machined them down so they're pretty much the same height as the top of the head. And we've now gone through and got rid of all that ovalness, as it were, so they're now lovely and round and the right shape or size or diameter for the pistons.
Well, they're just under the size, because now we've got to hone it.
So that's the next stage, basically.
Yeah.
Fantastic.
Doesn't matter perfectly where you set up on this, because it can swivel a lot, move a lot. And then this machine can also do other angles if you had a V8 or something.
Oh, that's clever. Yeah, okay, cool. And then it's all these little things on the bottom. Are they different grade stones or something? Or are they a lot
so I started with coarse stones, take it down to 2 thou.
Right.
And I use this second coarsest stone to take it down to a 1/2 thou.
Right.
And then the last 1/2 thou take out a finishing stone.
Right.
And I let it cool down.
Yeah.
Come back over if it's shrunk up a little bit, which it will.
Yeah.
I get it back on size again, then I cork it when it's on size.
Okay, amazing. So this is really rather like using wet and dry paper. So imagine obviously that works much better with maybe oil or water on it when you're actually just trying to smooth off a surface. Because what we're now doing, once we've got it down to the right size, we're then going to prepare that surface ready for the rings that are obviously inside or around the outside of the piston, and that's going to try and keep as much of the bang inside the engine rather than in the sump.
Yeah, so this is a setter. It's very simple. It just goes out to the edge of the bore, and then you put the stones in. And you're looking for a right number. So on a cutting stone like this, it's we do 10 to 13 on this scale, and then on a guide stone like these, a bit of bronze, to make sure they're right, and put them in the head. .350.
So it really doesn't actually take that much effort, as it will, or that much work to wear down that.
No, like I'm putting light pressure on one finger.
Yeah, amazing.
That just does it, yeah. So I've just taken, doing them 12 strokes there, I took out 2.5 thou, sorry.
So these are now the finer stones?
Yeah, the second set, because we're at 2 thou, so I'm going to usually take it down to 1/2 thou. It's cool down now for about 45 minutes to an hour. Make sure it's still the right size after it's cooled down, put a finish in it, and then face it. Yeah, it's not a lot of warmth, but you can't even feel it really, but it does change it.
Right, okay, so we'd rather have it right.
Yeah.
Having put this much effort in. So now it's basically the last tiny little bit of honing now, is it? So I mean, literally it's like a last little tiny bit of dressing.
Yeah, you can see it makes it, can you see it's a bit more,
yes, yeah,
makes it smooth, like more even.
Yes.
It makes it like one colour, like, but it doesn't take any metal off, it's just very fine stone.
It just sort of smears it around a bit.
Yeah, smooths out, makes it look nicer. Some stuff, like Subarus, the difference between an STI and a normal one, I believe in the casing, is just smoothness of the bore.
Really?
I think that's it. I believe so, yeah.
I suppose it actually you gain power by losing friction.
Yeah.
So the way we're going, this is going to be even better than the Ferrari engine, frankly, when it's finished. In fact, way better. So I have to bring that in next. So now this is obviously where we're going to now machine the top of the block. That's where the head is going to go, just to make sure it's not, even though you kind of machine down our new liners, it's now just making sure the whole thing is straight, no warps, no missing.
Aluminium heads can warp really bad if they overheat.
Right.
It's out like 30,000, make them flat sometimes.
Okay. Well, our head obviously is aluminium, so we'll do the same thing on this with the head as well to make sure that the head and the crankcase mate up beautifully. And you're now just you're just feeling your way really with the fly cutter, so it's just touching the top of the head, is that right?
Yep.
So it's like the beginning of a Duran Duran song, which you're far too young to know about. It's amazing how, like you're using your ears as much as you are your touch and the vibration stuff, just to actually hear how the machining is going.
Yeah. Like on that machine, you can't see after it's gone about an inch out of the board. You can't see anything. It's all about hearing it.
It's all about what you can hear.
See, it's touched there, and then like this corner here, and that's it.
So we definitely want to do the head as well, don't we?
Yeah.
So a little bit more to go.
Yeah.
So how much have we taken off so far?
Well, that was 4 thou. So it's be 5.
As you thought, yeah. And we're still talking tiny amounts of metal, aren't we? So
Yeah, 5 thou is nothing. Do one more cut and then finish. And finish after.
Okay. That's a good point. We've got to still put this together. And of course the pistons are going to be going in through the top. And we're going to have the fun of always trying to basically get the rings compressed around the piston as you then pop it in. So of course if there wasn't, you can now see a little bit of a chamfer forming. If there wasn't that little bit just to ease those rings in, it would be an absolute nightmare. And you can end up, if you kind of tap them a little bit too much or whatever, you can end up breaking the rings. So again, you have to start again with that. So this is, a really simple job, but it's actually vital. Again, all these parts of these processes are just, again, simple jobs, but together they make a really, really great job. It means that hopefully we can put this back together again and it'll work a treat. So basically, this is now done.
Yeah.
That's amazing. So effectively, we've now got our liners in place. They've been bored out and made sure that they're all kind of no longer oval. They're actually now round. They're exactly the right tolerance for our pistons. Obviously, you've now cleaned off the top. So now, of course, the top of our block is now also lovely and flat and got rid of any marks or any corrosion that was there before. So really, this is now good to go. It just needs to be washed, I guess, and a little bit of oil just to preserve it. So we get back in the workshop, we can start bolting it back together again. But there we go. Thank you very much, sir.
That's all right.
Grand job.
Thank you.
Wow, our forklift truck engine block has been transformed and now it's back at the workshop. It's almost impossible to tell anything's happened at all. Sure, it's shinier and cleaner, but actually all the magic happened on the inside, which is obviously where it really, really counts with an engine. Now obviously, now we've had our liners put in, had them bored out and had them honed to perfection. They're now ready for the fitting of our brand new pistons. But of course I can't actually fit that until I've taken the old ones off the conrods and obviously swapped a few things around, including a new gudgeon pin, or in fact a whole set of new gudgeon pins. So really this nice, simple, quick job is expanding as they always do in a workshop. And the next thing we have to do is sort out the head. Now when it actually came off the block, it looked relatively tidy. It was a bit dirty, but it all seemed to be pretty much in order. But actually it might not be. So we need to take the whole thing apart, have a really, really good thorough clean, and then inspect everything just to make sure that everything is the way it's supposed to be. And if it needs any work, well then we'll have to crack on with that as well. But all of that is a job for another day. Just hope the engine lasts long enough without rusting in this nice damp cold workshop. I'm just going to oil it and oil it and oil it.
Cause we were never being boring. We had too much time to find.